All right, let's continue with the unit circle. We're going to go over a few different things about it. So far, we've talked about radians. We've talked about how we find sine and cosine by looking at the points where the terminal side of the angle hits the outside of the circle, looking at the x coordinate for cosine and the y coordinate for sine. So in this, we're going to look at how we can find tangent. We're going to talk about negative angles, and we're going to just look at some other properties and rules we can use to find values of sine, cosine, and tangent on the unit circle. So first, tangent. Tangent is sine over cosine. And one way to think of that is on the unit circle, we've been doing a lot with 30, 60, 90 triangles. So remember, pi over 6 radians, that's 30 degrees. So I'm going to make a 30, 60, 90 triangle. And when I do that, we found this out last week that this side here is 1/2. That's the opposite side. The adjacent side down here is square root of 3 over 2. And we know that in SOHCAHTOA, tangent is opposite over adjacent. And here on the unit circle, the opposite always ends up being the sine because the hypotenuse is always 1. And the adjacent always ends up being the cosine, again, because the hypotenuse is 1. So to find tangent, you just take the sine over the cosine. So let's go ahead and find the tangent of pi over 6, of that 30-degree angle. And to find the tangent of this angle, we're going to do sine 1/2 over cosine, square root of 3 over 2. And when you divide fractions like this, one way you could work it out is by just the old way you learned, like in 4th grade, where you flip the second fraction, do its reciprocal, and then multiply. But what you'll notice here that happens is the 2's, the denominators, just cancel out. And what you're left with is 1 over square root of 3. Now, when you're finding tangent, what you'll have to do a lot is rationalize the denominator, because you'll notice as you go around the unit circle, you've got a lot of radicals, and those end up on the bottom a lot. So you have to rationalize it. So I'm going to do that down here where I have a little more space. And so what we do is multiply top and bottom by square root of 3, and we get square root of 3 over 3. So that's how you find tangent on the unit circle. You use the sine and the cosine, put the sine on top, the cosine on bottom. Another way to think of this is, remember, on the unit circle, sine is all your y values. It's the y value where the side of the angle hits the outside of the circle, and cosine is the x values. So another way to think of it is y over x. So whenever you have an angle, you have to find its tangent. Just take whatever the y value is at that point and put it on top. Take the x value and put it on bottom. All right, next thing is negative angles. So we talked a little bit last week about the initial side and the terminal side. So when you do an angle on the unit circle, you always start on the x-axis. This is the initial side of your angle. That's where you start. And then say I want to do an angle that's, let's do 2 pi over 3 radians. So what I would do with my other side is it would come up this way. And so this angle here is 2 pi over 3 radians. Well, if I want to do a negative angle, I'm going to do the same thing, except I'm going to go in the other direction. So for my normal angles, when I have a positive measure for my angle, I go counterclockwise. I start at the x-axis and go counterclockwise around the circle. If I want to do a negative angle, I'm going to go the other direction. I'm going to go downward. I'm going to go clockwise. So let me just switch colors here so it'll stand out a little bit better. So let's say I want to do, this is 2 pi over 3 here. What if I wanted to do an angle that was negative 2 pi over 3? Well, I still start on the x-axis on the positive side of the graph the same way I would. It's just I'm going to go the opposite direction. I'm going to go this way. And if I go negative 2 pi over 3, it's going to come right here. So these, if you look at the blue angle and the red angle, they open the same amount. So a positive angle and a negative angle in some ways are the exact same angle. It just has to do with their orientation. It has to do with which way you're going. And maybe a good way to talk about this is if you're talking about those as angles, it really wouldn't matter if they're positive or negative because obviously they're opening the same amount. What we want to think about here is rotations. So just understand that if you rotate counterclockwise, that is measured in positive degrees or positive radians. If you rotate clockwise, if you rotate clockwise, so start at the x-axis and go downward, that is measured in negative degrees or negative radians. So for negative angles, you're just going in the opposite direction. And you can kind of see where this ends up. If you look at the points where the terminal side hits, you get very similar numbers. And this goes back to another thing we talked about last week, where a lot of these points match up and the only thing that changes is the negative signs. So the only difference between these 2 points where we ended up is that the y value on the bottom one, which would be our sine, is negative. Notice the x value in both is the same. And we'll talk about that a little bit more later on. Actually, we're going to talk about it right now because we have these little rules. So what we noticed on that last slide is that if we have positive 2 over 3 pi, that angle, the sine is positive square root of 3 over 2, and the cosine is negative 1/2. And if we have negative 2 pi over 3, which puts us down here, our sine is negative square root of 3 pi over 2, and our cosine is negative 1/2. Well, what you'll notice about this, and this will be true of all angles, is that the sine of a positive angle and the same angle negative is just going to be switched. You just switch the sign. So you have this rule right here. If you have a sine of any negative angle, you can just find the sine of the positive angle and then make the value negative. So if you know sine of pi over 4 is square root of 2 over 2, and it asks you to find sine of negative pi over 4, all you have to do is put a negative sign in front of it. And you can see that on the unit circle too, because pi over 4 is up here. Negative pi over 4, we would go downward. We'd end up right here, and we can see the sign. It's the same numbers, just with a negative sign. So I'm going to leave that example up and erase some of this other stuff because I know it's a little cluttered. All right, if you look at the cosine rule, it's different. If you want to find the cosine, and remember cosine is your x value, cosine of a negative angle, it's going to be the same as the cosine of the angle without the negative sign. And you can see that on the one we've marked at positive 2 pi over 3, the cosine is 1/2, or negative 1/2, sorry. And at negative 2 pi over 3, the cosine is also negative 1/2. And what happens is when you have positive and negative angles, they're always going to end up on the same side of the y-axis. So they'll either both be on the right side or both be on the left side. So the x values will always have the same value. They'll always both be positive or both be negative. So the cosine of a negative angle is the same as the cosine of the same positive angle. Tangent follows sine. So remember, tangent is sine over cosine. So here's the thing, like if we have, if you look at sine of the negative angle, you made that negative. Cosine of the negative angle, that stays positive. And if you do sine over cosine, with what we've already found, you have negative over positive, and negative over positive always gives us a negative. So tangent, it uses the same rule as sine. If you do the tangent of a negative angle, you find the tangent of the positive angle, and then you make it negative. So I like to just use the unit circle as a reference and just look at my x and y values and work stuff out that way. But if you can remember these rules, they will save you a lot of time. We're not going to quite get into secant, cosecant, cotangent right now. We will come back around to that. But I want to make sure you're comfortable with sine, cosine, and tangent of negative angles. We'll look at some examples here. So here's the first examples, and these are just regular sine, cosine, and tangent of positive angles. I just want to make sure we're comfortable with how that works. So 5 pi over 6, that is a measure of an angle in radians. And we could make that degrees. That would be a 150-degree angle, but we need to get used to using radians. So 5 pi over 6 is going to be the angle that, as always, starts on the x-axis on the positive side and then opens up over here at this point. And so the sine is the y value. So the sine here is going to be 1/2. So if we've got the unit circle, if you have that handy, you don't need to work all this stuff out. You don't need to make the 30, 60, 90 triangles or do any calculations. So it's going to be 1/2. For the cosine, we have a 4 pi over 3. So cosine of 4 pi over 3, we find 4 pi over 3 on the graph. That's down here. So 4 pi over 3, whenever the numerator is bigger than the denominator, and I'm ignoring the pi, I'm just looking at the two whole numbers. Whenever the numerator is bigger than the denominator, you end up with fractions or angles on the bottom half of the unit circle. So it's down here. Cosine, of course, is your x value. So it's going to be negative 1/2. So the cosine of 4 pi over 3 is negative 1/2. And then the tangent of 7 pi over 4, that puts us down here. Remember, tangent is sine over cosine. So what we're going to do is we're going to take the two values, put the y value on top, so negative square root of 2 over 2, divided by positive square root of 2 over 2. And even when we got radicals and fractions, if we have the same thing divided by itself, it's going to be 1. And then with that negative sign, it ends up being negative 1. So the tangent of 7 pi over 4 is negative 1. And one thing you'll notice about tangents is whenever you're doing these, like pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4, those are like your 45-degree angles on the graph. And if you make a right triangle, you're going to get a 45, 45, 90 triangle. In other words, you're going to get something where the opposite and the adjacent are exactly the same. So the tangent there always ends up being 1 or negative 1. And we'll talk in the next video about where sine, cosine, and tangent are positive and where sine, cosine, and tangent are negative. All right. A few more examples, this time with the negative angles. So these are the same angles we did before, but negative. So there's a couple ways we could look at this. If we did sine of negative 5 pi over 6, what we could do is we could start here at the x-axis and count around negative 5, 6 pi. And one way we could do that is, if remember, we're going clockwise. So this would be 1/6, 2/6, 3/6, 4/6, 5/6. And it's going to put us over here. And remember, when we did the positive one, it put us up here directly above that. And what we should get is a perfect reflection of the positive one, which we do. So that's where it's going to put us. And we can tell just by looking at the point that the sine, the y value right there, is negative 1/2. Now, another thing you could do, let's go back here a second, is look at what we got for sine of positive 5 pi over 6. And we got positive 1/2. And our rule says that sine of a negative angle is just the sine of the positive angle made negative, or changed its sign. So what we could do is we just take that 1/2, make it negative, and now it's negative 1/2. And that's what we're going to do with the other two. So the cosine rule, negative 4 pi over 3. The cosine rule says the cosine of a negative angle is the same as the cosine of the corresponding positive angle. So the cosine of positive 4 pi over 3 was negative 1/2. So the cosine of negative 4 pi over 3 will also be negative 1/2. So for sine, we change the sign. For cosine, it stays exactly the same. Now tangent, when we did tangent of positive 7 pi over 4, we got, negative 1. And remember, the tangent rule is you change the sign, you make it negative, just like you do on the sign. So for tangent of negative 7 pi over 4, we're going to take that negative 1 we got, and we're going to make it negative. And when we have a double negative, that becomes positive 1. So for negative angles, you can look on the unit circle, go clockwise, figure out where the angle is, or you can just use those rules we learned, find the sine, the cosine of the tangent of the positive version of that angle, and then follow the rule. Make the sine and tangent negative, cosine will stay exactly the same. So last thing I want to look at are these examples here. And it says, these are straight from the book. And you're going to do for your assignment the odd numbered ones, 29, 31, 33, 35, 37. So we'll look at a couple of the even numbered ones. And it says the terminal point determined by a real number t is given. And the idea there is t is your angle. So we have made an angle t on the unit circle. We've drawn the sides. So it's kind of like something like this. Let me sketch this out. There's our unit circle. We've made an angle t, and it hits at a point, and they're giving us the coordinates of that point. And they want us to find sine, cosine, and tangent. And this is actually going to be really simple. To find sine, it is the y value, because these are points on the unit circle. It's the terminal point. That's where the terminal side of the angle hits the circle. So all you got to do for sine of t, and it's going to be t on all of these, is the y value, 4/5. Cosine of t is going to be the x value. That's going to be negative 3/5. And then to find tangent, that's the only one you have to do a little bit of work on. So to find tangent of that angle, what you're going to do is take sine over cosine. So y over x. So I'm going to take 4/5 over negative 3/5. And remember, what happens is the 5's just cancel out, and I get 4 over negative 3, or negative 4/3. So that's all there is to it for this type of problem. I just wanted to show it to you because it will come up. And let's do number 36 as an example, just to get a radical in there. Here we go. Okay, number 36, our sine, that's the y value. And again, we're going to call the angle t, is 2 radical 5 over 5. The cosine of t is just radical 5 over 5. So to find the tangent, we're going to divide those two things, put the sine on top, the cosine on bottom. And like always, the denominators are going to cancel each other out. And notice that you have the same denominators on all of these. And the reason for that is, remember, what this is coming down to is SOHCAHTOA, and sine and cosine are both over h, adjacent over hypotenuse, or opposite over hypotenuse. So they're always going to be over the same thing. The only time if you wouldn't get the same denominator is if just one of them would simplify and the other wouldn't. But a lot of times you have the same denominator, and those denominators cancel out. So what I get here is 2 square root of 5 over square root of 5. And now I rationalize my denominator by multiplying by that square root of 5. And what I get is 2 times 5 on top, and just plain old 5 on the bottom. Those 5's actually cancel out, and you just get 2. And you know what? You probably could have saved, you might have done this a lot faster than I did. You may have noticed before I even tried to rationalize the denominator, I could have just canceled those square roots of 5 out and been left with 2. So that is one type of problem you're going to have on this assignment. And remember, just for sine and cosine, all you got to do is look at the coordinates. Sine is the y, cosine is the x. The only one you have to work out is tangent. And a lot of times stuff will simplify pretty quickly, and you will be left with something nice and neat like 2 or say negative 4/3. So I hope that's helpful as we continue this unit circle stuff, and good luck working on this next assignment.